Today's experiment is Shake It Up, earthquakes and the damage that they do to buildings. I previously read that earthquakes happen when Earth's plates converge or diverge. It's coming together or pulling apart. When rock is displaced or moved during movement of the Earth's crust, a fault is formed. Fault is an opening. Faults can form by compressional forces of the plates, extensional forces of the plates when they come apart, or lateral movement when they shift side by side. The San Andreas Fault is an example of lateral movement in earthquakes. Energy is released from the epicenter, which is the middle of the earthquake. That's the strongest point of force, and it radiates outwards from there. And then we'll demonstrate how that affects surrounding buildings and the ground and how that movement is felt in our experiment. So, the experiment will show how the seismic waves spread and the damage that it can do to structures. Based on the construction of the buildings, we can determine which ones would be better for standing or withstanding seismic force of earthquakes. So the first part of the experiment is 4 different types of structures. And as we gently start the earthquake here, we'll see which structure topples first, and it was our tall one. And then the earthquake gets a little stronger and can be felt further out. Notice the buildings are moving. They're shifting and moving and breaking apart. This one falls and then this one falls. Now, even though this short, flat one didn't fall, we notice that it spread. So the seismic waves can cause things not only to topple if they're not built properly, but also to spread out and move. Here's the dot that was in the center, and now it's here. You can see the dot here and here where it was the center of those buildings. So the more stable buildings are the ones that are structured more soundly, and the ones that don't have as much support topple first. So, how far do the waves spread when the earthquake's going on? How far-reaching are the effects? We did a second experiment using the same type of building throughout, but placed at different distances. The first experiment, all of the buildings were placed at equal distances from the epicenter, but with the second experiment, we're going to place the buildings in different places at different distances. This is at 2 inches from the epicenter. This one's at 3.5 inches from the epicenter, 3.25 inches. And this one is 4.5 inches from the epicenter. And we'll see how that affects the construction, the buildings. All right, here we go. Epicenter falls first because that's where the strongest waves are felt. After it topples, earthquake keeps going. All right. All right, you notice the building closest to the epicenter has twisted and turned. The blocks are turning and they're spreading a little bit. The one at 3.25 inches, the bottom 2 rows spread the most in my other experiments, and the top 2 layers stayed pretty much stable. And the one furthest from the epicenter, nothing changed except for the very top one. So the structure is sound and can withstand the seismic force when it's not right on top of the epicenter, but the further away the building is from the epicenter, the better standing it is. So that's what we learned from this experiment. Buildings need to be structured more soundly if they're going to be located on fault lines or near where earthquakes typically happen. And the further you are from the center of the earthquake, the better off the building's going to be in the end, because they can withstand the seismic force. And that's what we learned at Shake It Up.